Welcome, and thank you for joining us for this webinar presentation. We are the Defense Systems Information Analysis Center, or DSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. DSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the defense systems community. As such, our organization supports those working in the defense systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the defense systems DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD defense systems research.
Good morning, good afternoon, wherever you are, to everyone here. Thank you so much for joining. My name is Taylor Knight. I am the technical lead for DSIAC, or the Defense Systems Information Analysis Center, as you just saw in our promo video. And I want to thank everyone for joining us today. We have a great webinar by Dr. Roberta Ewart with a title of In-Space Developmental Test Persistent Platform with the United States Space Force. So before I introduce people that we have here, we have a SME panel today, our first time, so we're very excited to have some experts in the field here to give some comments. I'm going to go over a few logistics, and then I'll do some introductions and pass it over to Dr. Ewart. But first, if you have any technical difficulties during this is being recorded, and we will upload this recording to our YouTube channel. So if you miss something, you can watch that at a later date from our recording. Also, we will have a Q&A session at the end of this, so if you have any questions at any time during this presentation, please enter them in the Q&A panel instead of the chat. You can get to the Q&A if you look in the bottom right-hand corner. There should be little ellipses. If you click on the ellipses, it'll bring a pop-up that says Q&A. That will take you to the Q&A session. And then I will kind of moderate that at the end. So at any time, enter any questions that you have during this presentation. Also, these slides will be available for download on our webinar website. So I will throw a link in the chat after my introduction so you can view them also at your earliest convenience. So today we have a little different setup. It's the first time doing this, so we're very excited. We have our main presenter, Dr. Roberta Ewart. She is the Chief Technology Officer transitioning between the Space Systems Command at Los Angeles Space Force Base and the Space Future Command. She was previously the Chief Scientist for the Space and Missile Systems Center in LA at the Los Angeles Air Force Base, and she is the Principal Scientific Authority and Researcher in the field of space systems. We also are being joined by 2 subject matter experts in the field. So we have Dave Barnhart, who is currently the CEO and co-founder of Archisys, Inc. He has a research professor appointment in the Department of Astronautical Engineering at USC, and he is the director and co-founder of the USC Space Engineering Research Center. He has an ultimate goal of working towards accelerating global innovation into space and has worked with a variety of people, including DARPA. Finally, we have Dr. Shannon Zerbel. She is an engineering manager in the Vehicle Engineering Department at the Aerospace Corporation. She's also a member of the Consortium Management Entity, or CME, team that manages COSMIC, where her responsibilities include leading the demonstration infrastructure focus area, and her research areas of interest are deployable mechanisms, space sustainability, and small satellite design. So what will happen is I will very shortly turn this over to Dr. Ewart. She will go through her slides and her presentation. And then after that, we will give 5 to 10 minutes for Dave and Shannon to discuss their thoughts and how their expertise lends themselves to this topic. And then we will open it up for a Q&A session from the variety of questions that we get from our attendees. So at this point, I'm going to hand it over to Dr. Ewert, and we're going to get started.
Hello, everyone, and thanks for attending. I've noted that there's 153 attendees. I scanned through the attendees roster. I see an incredible breadth of capabilities and approaches, different collaborators with different backgrounds. One thing I'm going to try to do today is I'm going to try to close the gap between those who practice in the software and cyber arena with those of us who practice more in the space arena. So I'll try to limit the number of words and acronyms that are more space specific so that we can better engage in conversation. So let me first go to the DSIAC community as a whole. It is my understanding that this community is helping solve key scientific and technical challenges, and you saw the movie here at the very beginning. But I want to drill down, especially in the areas of study, on how to mitigate the impact of cyber and electronic warfare. I don't know if some of the participants in the room know, but DSIAC was tasked with doing a study to mitigate the impact of electronic and cyber warfare technologies on satellites, with a particular emphasis on communications and navigation systems. The report was delivered in 2019. I went back and read the report, and some of the recommendations I'm going to use as a jumping off point for today's discussion. Two of those recommendations, developing routes of trust and developing lightweight cryptologic solutions for small satellites, were featured in the DSIAC report. Where I'd like to go now is to say the DSIAC report makes me think about what is the research, development, test, and evaluation strategy I would undertake to satisfy the recommendations that DSIAC has made. So literally, I'm listening to what the DSIAC community has said needs to be looked at, and I'm actually going to try to respond back to you as a subject matter expert. Please realize 2019 was some time ago. A lot of good things have happened. Neither Shannon nor Dave nor I will be able to cover all that ground, but what I'm going to feature today is how we can cover the ground even faster. How do we cover ground even faster in research, development, test, and evaluation? As we go to the test and evaluation realm, we rapidly test our candidates, get data, get that back to the field. Those of you who are software specialists, you may know this as more of a beta testing idea, where you get things out quickly in the community, get a lot of people working on it fast, get the data back, and then iterate. Also, aspects of agile would link up to this idea. So I'm going to quickly blitz through what appear to be space-centric ideas, but we want to close this gap between our cyber colleagues and our space colleagues who are working in this RDT arena. So let's go to the next chart, where I'm going to briefly go through an overview of where I sit as a chief technology officer. Basically, what's been happening over the last 20 years or so is chief technology officers in the military have been taking all of the information from above us, and we've been winnowing it down and figuring out what are the absolute things that we have to do with a very restricted budget. So all these things you see, we are working on. What I'm going to emphasize today is this the S&T that underpins this, and more particularly the test and evaluation that underpins all of the items on this chart. Why is T&E important? Well, it's on a key stepping stone path that we call technology readiness levels. Many of my colleagues in the cyber community may not know technology readiness levels. It's basically a step-by-step understanding that things mature. The higher the technology readiness level, the lower the risk and the better opportunity we have to transition whatever that technology is into a future program and then into the field. Remember the stepping stones. Technologies need to go into some type of program or a system deliverable, and then they go to field. We have no technologies that directly provide capability to the field. Okay, let's move on to the next chart. So we're going to go a little in depth on what is in-space developmental test. It's a type of higher fidelity test. So many of you may know we do tests on the ground. Dave is particularly knowledge of this, of his past, especially from DARPA. That test is really critical for gathering data. What we have proposed is to go even further with an advanced testbed that is unmanned, works as a robotic platform to do certain things, seeding technologies that will help the entire space economy, and as NASA calls it, a space superhighway. So those of you who've been watching how space is evolving, we're really hoping that test and evaluation can speed these technologies from all sources. They could be government technologies, industry technologies, or technologies from our universities. Get a quick valley of death on that TRL scale I just mentioned to you. There's actually several mini chasms or mini valleys that we have to get over. Won't have time today to give you a tutorial on that, but many of you realize that there's often a gap between a great idea, the first example in a lab, the example in the lab being made more robust and put into an environment, and then further being put into a system, and so on. Each of those steps is like a mini chasm where something could halt the progress. We want to remove some of those chasms and speed as quickly as we can the technologies forward. This is particularly important for cyber-based technologies because more and more the functionality of space systems relies on very advanced software functionality. In my business in the government, my job is to reduce acquisition costs, so that's also forefront in my mind. Now we're looking at how to instantiate this thing I've just described for you, in-space testbed. So we try to separate out the idealization of what we want and an actual example or a government reference design. So the government reference designs we're aiming for are the Advanced S&T or XST platform. And a couple of key items are listed here, particularly that it's unmanned and it'll be highly autonomous. Some of you may wonder why that's important. Well, every time we go to space and we have a human on the platform, we incur additional costs for safety of the human life. And there are things that are just too dangerous to put with humans in space. So that means we are highly restricted on what we can test on human-based platforms. So we're hoping that if we can go to non-human-based platforms, we can do some testing we otherwise couldn't do. We also want to have something that morphs quickly. I think Dave may address this. He has spent a lot of time looking at how we can do different morphing, different interfaces, rapid changes in the test environment, and being from more of the commercial side, he'll have more agility, and he'll probably speak to that shortly. As a government person, I want to accommodate as many payloads and open this up to as many possible providers. We may see in what is called in-space servicing come along and offer us even more candidates. I will also be working on space maneuver and logistics to enable the U.S. Space Force to be more agile in the warfighting environment of future space should the nation determine that we need to fight in space. We're still learning about that. I don't have time to speak about ISAM. That's something NASA colleagues would speak about. And you probably already know from my previous comment, robotics has a long history at DARPA. And maybe some of you didn't know this. If you're from the NRL, thank you very much for your contributions also in advanced robotics for space. Let's move on to the next chart. I'm going to try to leave more time for my colleagues to speak. Okay. Next chart, from an engineering perspective, once you have an idea in mind of how you want to approach a problem, you're going to start looking at a tentative mission timeline. This is like trying to tell your story in a diagram. And so on this diagram, we picked one of our possible design options, and we're trying to show you the thought process we are going through, the notional thought processes we are going through, so that we can make the outreach to the community. So let's start on the left. We won't be able to go through every item on this chart, but starting on the left, what we have accomplished to date is we've looked at all these possible test candidates, including the root of trust kinds of candidates, the cyber candidates, and we're trying to determine, can we accommodate these candidates on this in-space platform? That then goes to a requirements definition. And I don't know if there will be a chart coming up, but we break requirements down into buckets, and then our key engineers work in each of those buckets. And then we bring those engineering activities together and we merge them into a total design. We also have an interface definition. Everybody knows what an interface is. It's what happens when you plug in your coffee maker every morning to make your coffee. There's an interface of a 3-prong plug. Those types of interfaces need to be devised at every level of system integration, and we are no different in space. We're trying to understand what are the interfaces we need for the 3-prong plugs for space. Moving to the right, we're in the process of system development. I'm reaching out to this community to explain this to you so you can be with us on this journey. We will not be able to do this job without our colleagues in software engineering, software architecture, and we definitely can't do the survivability of these systems without our colleagues who understand the threats and can help us understand how to mitigate these threats. Won't be perfect, of course, but we need to bring in survivability early in the overall design of this system. The timeline will probably have to be adjusted fairly soon. For those of you who are following what happens in space, the International Space Station is aging out. It has been the test platform of choice for many of us in U.S. Space Force, U.S. Air Force communities. And when ISS is deorbited, that test asset will be gone. So it is necessary to start well ahead and figure out what gaps might the ISS demise create and what is in our best interest to either put in space or put on the ground to make up for the gap of the test capabilities we once had on the International Space Station. And again, I'm hoping my colleagues today will have more to say about that International Space Station follow-on capability. Next chart. Another thing we do in the space business is we like to make a storyboard, a storyline, so that people can follow why we're doing what we're doing. This storyboard is built left to right. The numbers that you see 1, 2, 3, 4, 5 in the amber box at the bottom relate to the 1, 2, 3, 4, 5 in the diagram above. Basically, they say we have a staged approach for rolling out our product. We're going to start with something easy and small. It has a name. It's a ring. Won't go into the details of that, but it's basically an ability to get something started fast, quick and dirty, learn a lot fast, and then adjust for the next steps, be they adding a NASA component or maybe a DARPA component or an NRL component or an AFRL component. But the idea is we want to be more agile, spiral more quickly, and adjust to our customers. Our customers will want to have their test candidates brought up to the asset to be put in the relevant environment. They want their data back from that environment. And then in some cases, they will want to maybe even have the test article back, especially for things like endurance testing, where they want to see how radiation or vacuum affects their product or their technology. And that's why we go from launching to the left, something simple, all the way to deorbit and disposal on the right. So you're seeing an entire life cycle concept of operations on this chart. Next chart. Here's the requirements chart. Okay, so as I said earlier, engineers have to break down problems into bite-sized chunks, and then we assign engineers to accomplish these tasks. Of particular note, technologies we would like to test include technologies that you'll see towards the L4, level 4 subsystem layer. So say there are products in thermal control, propulsion, or electrical power, or even computing. Those components and the requirements for their testing environment would be rolled into a requirements baseline as part of the design of our system. If you look to the lower left, I also mentioned the word survivability, again, because the DSIAC community is very good at advising from a cyber perspective, especially what things we need to look at to improve survivability of our systems from a software perspective. So for anyone who wants to talk in greater depth about the engineering aspect, the requirements aspect, Mr. Plotke is my chief engineer and holds the requirements trade space for me. Okay, next chart. The engineers also looked at a couple of design options. Earlier, we mentioned this term ESPA. So these little circles you're seeing, the orange circles with the shadowed boxes kind of on the outside, those are the structural components that allow us to be very agile in launching things to space. The middle design is but one approach. The other two designs on the left and right are slightly different. The left design shows how to use a type of ESPA ring in addition to a platform that might have robotic arms on it. And on the right is a more dedicated platform, purpose-built to actually be a laboratory. So the light green items that you're seeing could be viewed as the test candidates on the lab bench. So imagine like a long lab bench stretching out from the spacecraft that's in gray. And that's where one could emplace the test candidates for us to gather data. So the upshot of this is for you to understand the engineers can devise very different ways to create the test platform. All the platforms would be judged on how well they meet the requirements that we saw on the previous page. Okay, next chart. Of course, all of us know that decisions are made both on the value of the item we propose and also what we expect for cost. So what we have been doing at the same time as looking at the value proposition, we've been looking at cost estimation. You won't be able to read most of the items on here, but what we are showing you is the more simple ring that I spoke of earlier with various candidates attached to the ring and how we would go about costing this kind of effort. Industry has other ways to accomplish functionally what you're looking at on this chart. They have other ways to build the interface and bring the test candidates to that interface for test. Next chart. So what is the way ahead? Well, we are actually looking at detailed roadmaps and schedules for actually fiscal year 27 now. It's very likely that getting our dibs in on 26 is probably a little late. We are also interested in socializing and getting the word out, especially in this community. We think you can help us talk to a larger community, help us explain the value of testing, especially rapid cyber survivability testing and recommending rapid cyber survivability types of testing. And that's over and above the hardware testing we would do. We are out looking for the resources from our commands such as U.S. Space Force Test and Evaluation and the Test Resource Management Center, TRMC, who would possibly help bear some of the burden of the infrastructure of doing this amazing thing called In-Space Developmental Test. And with that, I've gone through some charts which hopefully have bridged a little of the gap between the DSIAC community of cyber experts to the hardware community of space professionals, and that overlap, that opportunity to collaborate will be in testing our technologies together, sharing the test data with each other, and then hearing from you, hey, maybe you should look at this type of test and this type of data to find out your cyber survivability capabilities. Other themes my colleagues Shannon and Dave may emphasize, and I'm now turning control back over to our MC, Taylor. Thanks again, everyone, for letting me to share the data with you today.
Great, thank you so much for a wonderfully insightful presentation. So I'm excited to hear from some of our subject matter experts in the field. I'm gonna have Dave Barnhart go ahead and kind of speak first, but please feel free, Shannon, if you want to, jump in and make this collaborative. It doesn't have to be a you talk and then he talks and then she talks. We can all kind of join in together. So I'll turn it over to Dave, but please feel free to jump in and let's kind of share our thoughts and kick off the conversation. Oh, Dave, you're muted still. Let me unmute you.
Hey, Taylor, do you want to take down the chart
Let me.
So can you hear me, Taylor?
Yes, we got
Yeah.
you.
Yes, Dave.
Okay, cool. Cool. All right. Yes. Thanks very much, Taylor, for the opportunity, and Dr. Europe for coming in. So to take a step back and sort of think about this in a bigger picture, every single domain that both the commercial sector and the military operates in, whether it's earth, sea, or air, you always test things ahead of time. In the past, in space, there has been tests that's occurred over many, many years, and it's typically been called hosted payloads. That's typically the methodology by which we ship something up, you get some idea if it works, and then it provides either a market path ahead for a commercial market, or in the military side, it shows a good technology path. The change that's occurred, and honestly over the last decade, if you will, is that the technology is now available to be able to do what I would consider to be more detailed levels of integration in orbit post-launch. And now that becomes really interesting because, to give you an example, in the commercial sector, one of the largest space accelerators around the world references phases of how space is changing. The first one was 1.0, and that was launched. 2.0 was data, which is large constellations. And they're referencing space 3.0, which is infrastructure. And in essence, what we're talking about here is a development platform that can test things, which is a piece of infrastructure. Now, what's really cool about this, in all honesty, is that if you can test things in orbit, this translates to manipulation, accepting arrivals of new cargoes, the normal things of how do you connect things together, of docking. Dr. Ewert talked about interfaces, which are nothing more than connectors. If you can do all that, that lays the foundation for what really is this next opening in domain, which is this big picture thing called servicing. And again, Dr. Ewert sort of talked about that. While NASA, we typically think of NASA as the group that does servicing because they have humans in space, i.e. the International Space Station. It's wonderful. There are, to date, over 100 companies, we validated this, around the world that are stepping into the domain of post-launch integration and manipulation of things on orbit. And that's really, really exciting. Thus, it points back to, from the U.S. standpoint, and especially for sort of military activities, and in many cases are dual use, that we are developing a persistent platform. In our case, I call ours a long duration platform, almost exactly the same. And the wonderful thing is great minds think alike. So at the same time as Dr. Ewert was coming up with iSDT, we were thinking sort of something, the same thing, but we use the word port. Because we're trying to get across that what we're really trying to do is in orbits, having safe locations that you can bring new vessels in and you can do things on platforms. And that's in essence what the In-Space Development Test platform is. So from that, I'll stop. The only thing I'll let you sort of indicate is that you might ask the question, well, okay, this is great. Where's the next step? And is there an indicator from either the commercial or the military side that is going to the next step? I can tell you that at the very least, there's one agency that is looking at it. We just received a SBR phase 2, which again is not huge amounts of money, but SDA is interested in what can a long duration platform do to support long constellations. And this is beautifully a segue into exactly why Dr. Ewert is developing this persistent platform, because if you can do that, now we can actually add things to spacecraft after it gets up. So I'll stop.
Thank you so much. Shannon, you want to jump in and share your thoughts?
I'd love to, thank you. So Dr. Ewert very briefly mentioned ISAM, and that's the area I can speak to. And then Dave spoke a lot about servicing, which is what the S in ISAM is. My background coming into this is working for the Cosmic Consortium on space mobility and ISAM capabilities. And ISAM is in space, servicing, assembly, and manufacturing. So having a test platform like this enables really all three of those, the servicing being the piece that we can tackle the easiest, kind of the first one to demonstrate. And as Dave talked about, with and Roberta as well, the astronauts on the space station are already performing many of those servicing aspects. But the question becomes, what's phase two? What happens not just after the space station is deorbited, but just what's the next level? How do we, step up and do the next piece? And so test beds that are established in space, a place where you can take your technology, your spacecraft, your robotic arm, those items, and prove them out in the space environment itself, will really enable getting across that valley of death that Roberta talked about, that this conundrum that within the space community we talk about a lot, which is that you can't fly until you've flown. This need to demonstrate heritage, to demonstrate capability in space before you can actually fly on a mission for the government or for a paying customer. And so test beds like this will help enable getting across that valley of death, that technology readiness level gap that so many technologies are unable to overcome at the moment.
Great, thank you so much. So I'm going to go ahead and ask a couple questions, get some more conversation started, and I'll open it up to Shannon, Dave, Roberta, and let us know your thoughts. So let's see, one of the questions we have first is, since testing in space is very expensive and likely has a long waiting list, is there a process to provide access to test results from other space-based weapon platforms in an effort to verify by similarity? Dum.
Yeah. No, I'm trying to break this up. It's a pretty, Scott is asking a very deep question. Yes, in a future world, we definitely want to have multiple verification approaches. Verification by similarity is one approach to verification. There are others. I do want to address the long waiting line and a process to assess test results. So ideally, let's go first with test results. Ideally, when you have a persistent platform, you have a communications downlink that is persistently providing test data in as an efficient a manner as possible to those who are flying their technologies. There would probably be some agreement prior to flying on a persistent platform how the test data would be shared or allowed to be accessed by others. Normally in the government, we try to make it clear that if you're flying, your data will also have government purpose rights. That may mean that another government agency may, by similarity, be able to compare your data to their data. However, they may be at a higher classification level than you. They may not be able to share back. They may not be able to say that they're looking at your data and verifying by similarity. So there's some nuances in Scott's question. It's a very deep question. Hopefully my colleagues can add a different perspective to the answer.
Yeah, it's a thing that we've talked about a good bit in the community that I mentioned previously. Being able to certify, to learn from others within the government, there's generally very, openness to sharing data to advance that. Understandably, industries, some of that is kind of becomes their secret sauce. We paid to get these answers, and we're not, it gives us a competitive advantage. And so, understanding that structure and respecting that right, I think. I don't think that question is answered yet. Really, is as to how we can definitely do the verify by similarity, but I think it brings up an excellent approach that can be applied, as Dr. Ewert said, with those agreements in place ahead of time. Certainly, there will be opportunities to do that, but have to respect those who own the data if they're not willing to share that as well, and that would be a reality that we'd face as we go forward.
There's another, I'll jump in, there's another potential way to look at this, and I apologize, I'm going to have to leave for a few minutes. I'm at another conference that's called, run by Confers, which is fascinating, right? But Confers was created out of, DARPA started and it went to a commercial consortium. And the whole purpose was to develop consensus-based standards for how to do operations, specifically related to reaching out and touching things in space, because it's typically been state-sponsored and focused activities. One key thing, literally, it's sort of funny, I'm on a panel right after this that's talking about validation and verification of bloody things that you put up in space that they're actually going to be able to connect. So a beautiful segue question, I must admit, to that. The fascinating thing is that at the moment, because this is a nascent and sort of growing entity, and Shannon knows this, and Cosmic is an organization that's supporting the U.S., Conference is supporting it internationally, the goal is to attempt to share information as much as possible without, crossing boundaries or getting into problems of export control, with the sole desire to, number one, maintain the highest level of safety, and then two, to increase best practices that I think would answer the question that would help us all sort of move forward. So I'll leave it at that.
Great, thank you. Our next question is, who do you envision would own, manage, and or coordinate the primary bus operations for the test bed in terms of scheduling payloads, managing power and resource allocations, communications, telemetry, etc.?
I should probably start that conversation as well, and I apologize, I'm going first every time here, but Greg, yeah. Where we currently sit in the government and in space test is we have a small space test program. We tend in the government that if there's already a group kind of working in that area and they kind of have some of the expertise, we tend to want to go to that group and say, okay, how do we grow you? So my belief is we would leverage an existing smaller organization. We'd have to grow that organization. It's currently bedded down in Albuquerque beside the Air Force Research Lab. It was once called the Space Development Test Wing. It has a different name today, but nevertheless, the bona fides of space development and test has never been broken. So I would say it would be that unit at Albuquerque, possibly renamed and grown, would manage and or coordinate operations which could actually be commercially run. So it could be a government-owned platform where the government, the United States, pays for, through the taxpayer dollars, the basic infrastructure, and then we then find how can commercial industry be as efficient as possible. It's called a GoCo. So that's one possibility for managing and or coordinating the primary bus operations for the test bed, scheduling the payloads, which anyone who's been a scheduler ever, it is one of the most complex social problems you can ever have because you have multiple priorities, multiple constituencies. There's a sense of fairness, transparency, judiciousness that have to be applied, right? That's an art of the deal between industry, academia, and government. And then managing all those resources, getting the common telemetry down, likely through an existing but growable system that we're currently using for the space test program. And by the way, links to our NASA colleagues who fly space test program candidates today on the International Space Station. So in summary, Greg, likely a government entity would start the infrastructure. Likely commercial would be the most efficient to help us coordinate and schedule. And then it would be a community-wide effort, maybe even Confers or something like it would have to be invoked to get the resource allocations and the test data out as appropriate. And additional comments, turn it over to my colleagues.
I think
Shannon, if it's okay, I'll go quick, and then I've got to bail. What's interesting is that one of the first things that we started working on with the activity that I have at the company was to answer this question of how to do all this scheduling. So you have to take a step back and think about it. What are you trying to schedule? You're not only trying to schedule the arrivals and the departures, let's call it that, bringing new payloads and new tests up, but you're also attempting to schedule sort of two things, if not more, that are competing with each other. The first is the platform itself has to be a platform. It has to fly as a spacecraft, which means you have to see the sun, you have to maintain inertial stability, et cetera. So you have to sort of stabilize yourself first and foremost. Second is you're going to have different test apparatus and groups that want to look at the sun, they want to look at the stars, they want to look at the moon, they want to look at the Earth, all at the same time, and all saying, hey, I'm the most important one, right? We actually have created something internally to look at how to adjudicate the optimization of both time and usage of the platform to be able to satisfy this. Now, on the commercial side, I'm not going to answer on the government side. Dr. Euro can, she can go in and fight with all the cats there. But on the commercial side, the easiest thing to do is, you guys want more time? No problem. Pay up, right? You can have tiers level that you can support that. So sort of quick answer. That's in essence how we're trying to do it. I must apologize. I'm going to head off to the next panel. Thanks very much, Dr. Hubert and Taylor, and I apologize leaving in the middle of this. Thanks, Shannon.
No, thank you, Dave.
Cheers. Okay.
Okay.
I won't add anything on that one. I think those are two excellent responses from the two different aspects. So thank you both for
Thanks,
those
Shannon.
thoughts.
We'll move on to the next one. After separation from the launch vehicle, how are payloads delivered to and then integrated onto the Advanced Space-Based Testbed?
Taylor, I'm not seeing the words. Could you in the chat, could you repeat the question?
Sure. Yep. So this one's in the Q&A. It's after separation from the launch vehicle, how are the payloads delivered to and then integrated onto the Advanced Space-Based Testbed? Oh, I think in the diagram that Elazar made, could we, sorry, you may have to go to a chart to help us. Yeah. And I'm only going to speak for our ConOp team. Go down a little further. Okay. So there should be something on here that shows how the servicer gets these test candidates up there. And if I'm not seeing it right away, Elazar, if you're in the room, help me out here. There should be something on here that says there's an entity, a free flyer, that brings the candidates up under positive control. We want to make sure we do no harm to others. We abide by the rules of how to move in space, and everything is safe. Elazar, where on the chart is the, oh, there it is. It's kind of in dark black in the center. See where it says tender servicer vehicle? Can you guys see that? Yes. There would literally be positive control. The tender servicer would be on a launch asset. It would separate from the launch asset, approach the testing platform, however it's designed, and there would be protocols for that tender servicer to interact with the testing platform. When Dave was talking about the port, right, and you want to imagine ships coming into a port, right, you kind of make sure that the ship has a pilot that's bringing it in and gets it lined up, and it doesn't bump into anything, and it doesn't scrape on the ground, and then you get it lined up to its berth. And then maybe you stop a little short of the berth and you like wait a second to make sure everything is okay. And then you exercise more positive, either grasping or a soft docking and then a hard docking technology. So the naval analogy may break down there, but it's this staged positive control process from the moment we separate from the launch vehicle all the way to where we're actually at the testing platform and we have to move our candidates off of their tender and onto the test asset itself. Back to you, Taylor, if anyone else wants to pile on.
Actually, I just want to mention also that we, in the far right of that diagram, we talk about test payloads coming up, and they could be hosted payloads that are on another space vehicle, that they get ejected from the space vehicle and then can be grappled by a tender servicer that can then be brought to the test bed, or the test bed itself, which could have long arms can actually grapple those as well if they get to within its reach. So we're constantly thinking about ideas on how to do that. We appreciate the question. I think it's excellent. And we are thinking about how to go about doing that, those activities. Appreciate it. Thank you.
Great, thank you. Our next question is, if using Agile and DevSecOps for software development methodology, how are you handling software safety and reliability throughout the sprint delivery cycle?
All right, I guess I'll break the ice here. My tendency is to want to containerize something before I let it just roam freely within my system design. I believe our colleagues in software architecture, such as the Software Engineering Institute, have devised protocols, best practices. Also, DSIAC is in an amazing position to advise us on this very thing, and that's one of the reasons I'm here today, is I'm actually looking for more insights to accomplish that kind of software safety and reliability, because the next step after safety and reliability is survivability. If we in the government side here can't deliver a survivable piece of capability, it does the warfighter no good. So in sum, I think the answer is likely a containerized approach. Likely Software Engineering Institute and DSIAC could help us work that issue as expeditiously as possible. But remember, when it's a DoD application, it has to be survivable, not just safe and reliable. Thank you, Sean, for the question.
Great. Next question is, let's see. We have an attendee who says he's been fortunate enough to spend over 7 years supporting the DoD space programs. So curious in knowing what the current percentage of foreign partner participation is in getting USSF capabilities to space, and is most of that infrastructure and manufacturing?
I do not have the statistics on the current foreign partner participation.
Okay.
But I think Dr. Ewert, we want to make sure to let everyone know, I think Dave mentioned about 100 or so companies that are going into this space and interested in doing servicing. So it's becoming its own area of interest for space vehicles to get capabilities to do in-space assembly and in-space servicing. And I think Peter actually threw up here a number of companies, Astroscale, Starfish, some of the big integrators like, let's see, Northrop Grumman and others are expressing great interest in this area. And so we expect that this is going to be a growing and advancing quickly and accelerating quickly in the space to create a super highway of space from here to wherever we want to go in space.
Mm-hmm.
Thank you.
Can I pile on to that a little bit, Elazar? There's also there's actually nuance here that has two answers. Foreign partner participation could be foreign government to U.S. government. And then I believe you're calling out foreign company to possibly American company, American government. So very correct, Peter, calling out Astroscale. Let me give an example to the community. Astroscale, I believe, is a Japanese entity. They are working directly with a U.S. Space Force Colonel Joyce Bolson. Their program flowed the funding to Astroscale. So in that case, that was a U.S. government to foreign company. So again, there's a bunch of nuances here. Yes, there are many companies, there are many relationships, but as far as me making sure, I can't tell you the percentage because that was the question asked, but we have given you at least a bigger picture, and maybe someone can go online and aggregate the data and tell us what the percentage is, but I haven't had the chance to do that.
Make it a collaborative effort.
Yeah, and you just run out of hours in the day to, you know what I mean.
Okay, we have a question for the way ahead slide. The question was, like the International Space Station, do you think that this in-space test platform will require White House support? And if so, what do you think is the best way to get national leadership support?
Anytime you put yourself in the class of sentences, oh, follow the International Space Station, I'll tell you right then, if, as I have done, I have now opened myself up to the necessity of appealing to higher authorities like the White House, the Office of Science and Technology Policy. I think it's wise to do that to get the highest levels of our government interested in doing technology advancement for the nation as a whole. So I think it's definitely, yes, we will at some point go to the White House. And then what was the second part of the question?
If so if you will go to the White House, then what do you think is the best way to get national leadership support?
I think what we're looking at is how to bring industry along. We don't want to make this look like just the government going off and doing something. I think there is ever greater an interest in ensuring that our strongest companies, our best companies, and our best innovators are brought to bear and bring their strengths, while I possibly bring the government strengths, which are things like government can sometimes not look at the profit per se and say, you know, this has an innate goodness. We've got to kind of bridge this problem until we see the value model emerge. We might be able to supply some stability that the market alone, commercially alone, can't provide. So, guys, I think it's a matter of we bring the goodness of the government and industry, and by default academia, into a relationship that then the White House blesses as a unified strategy. I don't think it's going to come down as the White House says, Space Force, go build your test platform. I think that is not going to be the most likely. I think the
Drop off a bit, Dr. Ewert. Oh, yeah, I think we lost your comms. We see you.
Taylor, are you still there?
Oh, we got you.
Oh, okay. I wasn't sure. I stopped talking. And it's like, I better say over or back to you.
That's okay. We dropped the last bit of it, but we're back on track now.
Okay, great.
Great. So in an effort of time, we have a couple more questions. I'm going to try to get them in. The next one is, this one was in the chat as well. Do you envision the test platform being able to change orbital azimuths and altitudes depending on payload requirements? And if so, that would take a substantial amount of energy and propellant. So is it capable of being serviced itself? And could such operations be done without compromising the hosted payloads?
I believe Greg is an excellent engineer and he's pointing out key downboard questions. So let me go back. When you are on a very strict budget for design of a future idea, you have to narrow your trade space to meet the available study dollars. What I think will happen is, as we get the word out, we're going to attract more study dollars, Greg. As I get more study dollars, I can widen the trade space. As I widen the trade space, I can look at things like changing orbital azimuths, attitude, payload requirements, based on the more practical aspect that we would have the money to do the analysis. I totally agree. It would take a substantial amount of energy and propellant to move a large object. That's F equal ma, absolutely true. But that may lead us to, well, why can't we make the platform itself refuelable to give us those options? We can create all these nifty off ramps for everyone to put innovation into the discussion. So I think your question leads us towards the future where we broaden the trade space, get more study money, or we work with others to bring their analysis into the trade space. And then we go deeper on these physics and engineering questions to prove to ourselves, yep, we want to service it. Do we want it to be a 10-year platform, a 20-year platform? do we want to have 20 degrees of inclination change? Do we want to have, 1,000 kilometers orbit raising capabilities, and so on? Hopefully that got Greg's question.
You have time for two more, so I have two queued up. The next one is, what is the interface with OTTI?
Man, I feel like I'm taking all the air out of the room. Okay, operational test is run by Colonel Klopstein. He's a program executive officer. He works with particularly our Star Command, Space Training and Readiness. They are laser focused on operational test. There's a difference between operational test and developmental test. One of the key things developmental testers do is we bring down the cost and risk for the operational tests. My interface, and it's not like plugging, a physical interface, it's a mental and programmatic interface. I see us as bringing down the cost, the time, and the risk. Get all that risk from a technical perspective as much off the page before we give it to the operational test and training PEO, so he can then wring out the neck of this at that higher systems of systems. Operators are in the room pushing actual buttons from their consoles versus, I don't think we're slewing this star tracker as many degrees as we thought, so we're not getting the data we need because we're not seeing Betelgeuse. So there's a huge difference between developmentally testing something and operationally testing something. And I see us as supporting and enabling even greater and better OTTI.
Thank you. And then our final question, just for the sake of time, is, looks like it's about the requirements slides. Let me get here. It says these requirements have been shared with industry partners. So is it better for the USSF to do in-space test as a service, or do you think it's necessary for the USSF to own its own platform due to security concerns?
I think the Space Force will have to retain some in-house, not service capabilities. And I think it's primarily up to the secret collateral level. I don't think we're going to be able to come up with a cost-effective platform that goes above that security level. So as long as U.S. Space Force needs to test up to the secret collateral level, I'm not sure it's feasible cost-wise to do that as a service. It may be possible, I just haven't come across it, but right now, I think we may have to keep that in-house.
Thank you. Well, we are just about at our 1 hour mark at 1 o'clock Eastern time. Are there any other comments from you, Roberta, or Elazar, Peter, Shanna, anybody that's on the panel that you want to end with?
Sure. I'll just say some big picture. I mean, most of the questions were very specific to this, particular concept, which is appropriate. That makes sense. That's what the topic is for today. Dave talked a little bit about another, platform that his company is working on developing, and there are so many similarities because you narrow down that trade space in similar ways to what are the things that you can tackle best first. So a lot of these questions talk about, like how will you do this specifically? But I think they're great opportunities to think about what are the next steps, or how might another company look at this in a different way that might resolve different concerns with a risk balance, right? Like you trade off different risks to provide different capabilities or different aspects of servicing there. And the other thought that I had at one of the questions was, thinking of the political environment. I think that was a little bit, it was how do you get the national leadership buy-in maybe, and certainly there's a whole aspect that we didn't talk about, but the this is the defense system, or this is DoD, right? Like where defense is a big part of that, and space right now is a very critical element in warfighting and discussing how we are maintaining our national capability here. What are what are the benefits that will be offered by having a test platform of this nature to advance our capabilities and resilience in, and resilience comes through servicing and some of those elements that we talked about. So we are over time, so I'm going to stop there, but just kind of hinting at that security side, the national security side of space too. Thank you.
Well, I definitely know that I appreciate everyone's expertise that has weighed in and that joined. Thank you so much, Shannon. I know Dave jumped off earlier, but Dr. Ewart and her team, Elazar, Peter that joined. I learned a lot. I know that everybody else has done some great comments in the chat and in the Q&A. So with that, I kind of have the emails of Dr. Ewart and her colleagues on the slide. Please feel free to reach out to them. Shannon, would you like me to share your email address as well? I can drop it in the chat.
Sure, that's fine.
Okay, great. So if anybody has any further questions, I can drop that in the chat. But again, these slides are available for download on our webpage. The link was also shared earlier in our chat. Thank you so much. We really appreciate it. And with that, I hope everyone has a wonderful day. Thank you. Bye, everyone.